In this video, we're going to investigate an incorrect computation. What is wrong with the following computation? The integral from minus 1 to 1, 1 over x squared dx is equal to integral from minus 1 to 1, x to the minus 2 dx, and reverse the power rule, we get negative 1 over x, apply the fundamental theorem of calculus, put the upper limit in, we get minus 1 over 1, minus 1 over minus 1, and we get minus 1 is equal to minus 2. Intuitively, we know the answer, negative 1 to 1, 1 over x squared dx equal to minus 2, must be incorrect. Why is that? It's because the integrand, y equals 1 over x squared, is a positive quantity for x between negative 1 and 1. Therefore, the integral, which represents the area under the curve, must be positive. And we have a negative quantity here. So we know something is wrong. So let's illustrate with a diagram. The integral from negative 1 to 1, 1 over x squared dx represents the shaded green area, this area here. And since y equals 1 over x squared lies above the x-axis, the integral, negative 1 to 1, 1 over x squared dx, must be positive. And therefore, the integral from minus 1 to 1, 1 over x squared dx equal to minus 2 must be wrong. This example shows the importance of checking the conditions of the fundamental theorem of calculus. The fundamental theorem of calculus states that the function must be continuous and bounded on the interval, closed interval AB. Clearly, this function y equals 1 over x squared is not bounded at x equals 0. In fact, there is a vertical asymptote at x equals 0. The function blows up to infinity at x equals 0. So the integral from negative 1 to 1, 1 over x squared dx, is an improper integral because the integrand, f of x equals 1 over x squared, is unbounded and has a vertical asymptote at x equals 0. It is discontinuous at x equals 0. The limit as x approaches 0 of 1 over x squared goes to infinity. So let's do it the correct way. So what we have is integral from negative 1 to 1, 1 over x squared dx. This is equal to, we're going to split it across its point of discontinuity, we're going to split it at 0. So we integrate from negative 1 to 0, 1 over x squared dx, plus integrate from 0 to 1, 1 over x squared dx. Now, notice that the function f of x equals 1 over x squared is an even function. That's because f of minus x is equal to f of x. Or equivalently, f of x equals 1 over x squared is symmetric with respect to the y-axis. We can see this in the previous diagram. Y equals 1 over x squared is symmetric with respect to the y-axis. It's an even function. Let's actually prove that. F of minus x is equal to 1 over minus x all squared. That gives us 1 over x squared. That's equal to f of x. So we can see the function satisfies the condition for being an even function. All right, so the integral from negative 1 to 1, 1 over x squared dx, we write this as integral from negative 1 to 0, 1 over x squared dx. Let me clean this up a little bit. Integral from negative 1 to 0, 1 over x squared dx, plus integral from 0 to 1, 1 over x squared dx. But because it's an even function, we can write this as 2 times the integral from 0 to 1, 1 over x squared dx. That means we only need to compute the second integral and just multiply it by 2. So the function is symmetric with respect to y-axis. That simplifies our computation. So the integral from negative 1 to 1, 1 over x squared dx is equal to 2 times integral from 0 to 1, 1 over x squared dx. So integral from negative 1 to 1, 1 over x squared dx is equal to 2 times integral from 0 to 1, 1 over x squared dx. Writing it in proper notation, this is limit t approaches 0 from plus side, 2 times integral from t to 1, x to the minus 2 dx. This is equal to 2 times. Now we'll reverse the power rule. We get x to the minus 2 plus 1 is negative 1 divide by -1, evaluate it from t to 1, and take the limit as t approaches 0 from plus side. Let's simplify this. We get limit t approaches 0 from plus side minus 2 over x, evaluated from t to 1. Put the upper limit in, we get minus 2 over 1 minus 2 over t. Take the limit as t approaches 0 from plus side. That's going to give us -2 because the limit of -2 as t approaches 0 from plus side is just itself. And then minus is plus, and the limit of 2 over t as t approaches 0 from plus side is infinity. So the answer is infinity. So what we have shown is that the integral from -1 to 1, 1 over x squared dx is equal to infinity. That means this integral diverges. All right, thanks.